everyone, I'm Gargi.
Hello, I'm Rizzo. Today we're going to be presenting Current Bench, which is an infrastructure for continuous benchmarking of OCaml projects that we have been working on for quite some time now. So the goal of the project is to provide a scalable, predictable, and continuous infrastructure for benchmarking OCaml projects. The aim that we have is really to support benchmarking as part of the CI process of any GitHub repository that is part of the OPAM ecosystem. And we want to make it as easy as possible. So any project right now can just enable the benchmarks without any additional configuration or any setup and start benefiting from running benchmarks and kind of analyzing the historical trends in their performance over time. We started with a fairly small selection of projects and users to kind of develop the system and figure out what are some of the important features that we want to build. Specifically, we designed the system around benchmarking for the Irmin family of projects. So we have 3 projects right now from the Mirage and Irmin ecosystem using the continuous benchmarking infrastructure. More recently, we also added support for Dune benchmarks, where people are measuring the build performance of the build system that we use in OCaml. And we're also currently integrating the project with the multi-core backend for the OCaml compiler, and we have some work in progress tooling to support running the Tezos benchmarks. But again, as I mentioned, the goal is really to get to supporting as many OPAM packages in the ecosystem as possible in the future. We have 3 different operational modes in which we can run the benchmarking infrastructure. The main one and the most interesting one for most of our users is probably number 1, which is the GitHub application. So we have actually created a GitHub application that you can go to and enable for one or multiple projects in your account. And that will essentially allow us to monitor every single pull request and commit that happens in your repository, so we can schedule and run benchmarks and collect results from those benchmarks and present them in a UI that you can explore. But in addition to that, we also created 2 supplementary operational modes that essentially allow people to focus on monitoring a single GitHub repository or even a local file system based Git folder. So those 2 are mostly used for testing purposes or for some specialized deployments. If you want to hack on Current Bench, you can probably use it on your local machine with the local repository operational mode. So this is how the project looks like. We have a fairly comprehensible user interface that allows people to explore the benchmark results over time. You can see here that we're looking at the Mirage Irmin repository and specifically at one of the pull requests that was submitted. So in this picture, you can see all of the different metrics that were recorded as part of the execution of the benchmarks. You see the latest value from the specific pull request, the equivalent value on the master branch, and also the deviation from master. The graphs also include computation for standard deviation and include error bars so that it's much easier to track outliers throughout the history of the benchmarks execution. The project is actually live and deployed at autumn.ocamllabs.io. We'll change that at some point, but for now you can go there and explore the UI, see how it looks like, and just get a feel for it. At the back end of this platform is actually powered by Current, which is a super handy and useful library that allows us to essentially keep things up to date and monitor all of the sources for changes. Specifically, we, as I mentioned in the beginning, connect to the GitHub API, and we monitor that API for changes. And whenever there's a new pull request or a new commit, our current backend, which we also call a pipeline, will detect those changes and trigger an execution of a bunch of computations that are required to get the information about the pull request, understand how to execute it, build Docker images and execute those Docker images to actually record the results and store them in the database. To tell you how the project actually works on the inside, I'm going to hand it over to Gargi, who's going to tell you all about it.
Hi, everyone. So as Reza mentioned, I'm going to talk about the internals of Current Bench. So this is what the infrastructure looks like. We have an OCurrent pipeline. We store the results in a database that the front-end queries over the GraphQL interface and then puts it on a website for the user to see. When you open a new PR, the first thing that happens is a webhook event is triggered that the pipeline receives. The pipeline then goes and looks for a make bench target in your project and runs the benchmarks inside a Docker container. We've done a bunch of optimizations to ensure that there's no noise when we run the benchmarks that I'll talk about later. Once the benchmarks finish running, the pipeline puts it in a database and updates the status on the GitHub PR. So once the benchmarks finish running, the PR status on the GitHub pull request is updated, and you can go click on it and look at the results in the dashboard. The benchmark results is just a simple time series result, which we store in the Postgres database. So it has a bunch of information about when it's run and the commit and branch and pull request information. And you can have multiple benchmarks in the same repository. And we support having multiple benchmarks in your repository, and those benchmarks can have the same test name. That's okay. And all the metrics we store inside a JSON that the front end then uses. So the hardware optimizations that we do is that we pin the benchmark to a single CPU. So at any point of time, we're only using a single core and the benchmarks are scheduled. So we run one benchmark at one time, so there's no noise that can fudge the numbers. For IO performance, we have our TempFS partition, and we pin the TempFS volume to a specific NUMA node, and we disable the address-based randomization so that it doesn't introduce any noise. This is the work that Tom Kelly and Sadiq did for OCaml multi-core benchmarks, but they run the benchmarks natively, and we run them inside a Docker. If you want to enroll your project, it's super simple. You go to OCaml benchmarks GitHub app on the GitHub Marketplace. You need to have a make bench target in your repository, and you need to produce a JSON that is compatible with current bench. So you just have the name of the benchmark and the results. And you can have multiples of these JSONs for like different kinds of benchmarks you have in your project. And yeah, that's it. In the future, we want to have a bunch of improvements. So we want to allow users to query data using GraphQL, so that if they want to play around with the data, know something more, or have graphs that we don't support, they can do that. And allow custom Docker files. So if your benchmarks need pinning of a certain OPAM package, or want to get some data from somewhere and other things, we want to allow the users to do that also. And allow the capability for fast and slow benchmarks. So maybe on your pull request, you need faster feedback. So you want to run benchmarks that can finish fast. But you also want to run other benchmarks that you care about, just not for the pull request. So maybe you want to run them nightly or weekly. So we want to be able to support that, and we want to provide detailed stats. And basically, our grand vision for the future is to have continuous benchmarks for all OCaml projects, which is a challenging and a very interesting problem to solve, given that we only run benchmarks on one core at the moment. So scaling is something that we're looking to do, and very excited to face the challenge and look into how we can do that. Yeah, and that's it. And we'd like to acknowledge all of these people who contributed to Current Bench and yeah, got us here. And that's it. Thank you so much.
Thank you.
Bye.